So let's look at this whole idea of rationalizing a denominator. If I'm dealing with 2 over the square root of 5, I want to get rid of the square root that's in the bottom there. It sure would be nice if I could just square it. No, I can't, so don't write that. I can't just square it, so that kind of sucks, but it would sure be nice if I could. That'd get rid of the square root. Well, what does it mean to square something? Well, it means to multiply it by itself. So it'd be sure nice if I could just multiply by the square root of 5. Well, I can't do that, but what I could do is I could do it on both the top and the bottom. In doing that, I'm multiplying by 1. That gets me 2 root 5 in the top and the square root of 5 squared in the bottom. And the square root and the square undo each other, leaving me just the 5. And so now I no longer have a square root in the bottom, which was my whole goal, really. Now, I do want to point out, we don't just multiply by whatever's in the bottom. On this next example, we're not going to just multiply by the square root of 9x. Our goal is actually to bring ourselves up to a perfect square. So one thing I want you to do and to get in the habit of, and we've mentioned this before, is anytime you have a number that can be written as a power, do so. So 9, you want to write it as 3 squared. And the reason for doing that is we see this is already a square. I don't need to mess with that portion of it. The only thing I need to mess with is the x. I need to bring the x up to a perfect square. So I have one x there. I'd like 2 of them, so I need one more. So I multiply by root x over root x, getting me 5 root x in the top. And in the bottom, I've got the square root of 3 squared and the square root of x squared. The square roots and the squares undo each other, so that in the bottom, all I have left is 3x.